Hello everybody, so I've been getting a lot of questions on how exactly to derive equation 6 from your one-dimensional collisions lab manual using equations 3 and 4, where equation 3 is just a conservation of momentum and equation 4 is just a conservation of kinetic energy, which remember is only true for perfectly elastic collisions. So equation 6, which is our end goal, looks like this, which is straight from the lab manual. So the ratio in the difference of the final and initial velocities is -1. And we're also going to use equation 4. This is the conservation of kinetic energy, or Coke. And I'm going to write it without the factor of 1/2, since there's a factor of 1/2 on every single term, it just cancels. That's m1 v1 initial squared. And then the kinetic energy of the initial cart 2, which is equal to the kinetic energy final squared of both carts. And equation 3 is just the statement of the conservation of momentum, COM. Oh, excuse me, that should be a plus sign. So this is the momentum for the first cart, initially, momentum for the second cart, initially, and that's going to be equal to the sum of the momentums of the final state. That's m2 v2 final plus m1 v1 final. So you might be asking yourself, what is the first step that you need to take to go from these two equations, which have velocity squareds and regular velocities, and also m1s and m2s? Well, a thought process you might make yourself in order to motivate the very first step of this idea is notice that equation 6 actually does not depend on the mass at all. So you need to do whatever you need to do in order to cancel out the masses. And the way that you would go about doing that is to arrange both equation 4 and equation 3 with m1 on the left-hand side and m2 on the right-hand side. And then if you divide the two equations into each other, both the m1 and m2 will cancel. So let's go ahead and do that. First, I'll arrange equation 3 with m1 on the left-hand side only. So m1 v1 initial can stay, but this m1 v1 final on the right-hand side has to move over. And then this m2 v2 final stays, but I have to bring m2 v2 initial over to this side. So we can rewrite this now as m1 v1 initial minus v1 final. So I'm factoring out the masses from both sides. And I'll do something similar for the conservation of kinetic energy equation. So the first term stays, and I bring the term that's initially on the right-hand side with m1 over to the left-hand side. And the same argument for the right-hand side. And I'll go ahead and factor out the masses. Excuse me, that should be v1 final. Okay, now if we divide the two equations into each other, we'll know that we'll cancel out the masses. And you can figure out which one of these equations should be the numerator and which one should be the denominator, because you know the final equation is in terms of just the velocities. So if we divide equation 3 into equation 4, all the masses will cancel, and the v squares will be turned into just regular v's. So let's see how that happens, actually. I'll go ahead and write in 1, I'm just copying down this equation here, the left-hand side being done first. And let's divide that by the left-hand side of this equation here. So we're dividing this term by this term here. So that has an M1, and then a V1 initial minus a V1 final. And we'll go ahead and repeat the same step on the right-hand side. So now I'm writing down the right-hand side of my kinetic energy, my rearranged kinetic energy equation. That's M2 V2 final squared minus V2 initial squared. And then for the denominator is going to be the right-hand side of this rearranged conservation of momentum equation. So that's M2, and then times V2 final minus V2 initial. I need to scroll to get a bit more space. So we can see immediately we have something invariant in mass now, and I'll just go ahead and rewrite what we have all in one color. So we have V1 initial squared minus V1 final squared over V1 initial minus V1 final, which is equal to the right-hand side, V2 final squared minus V2 initial squared, divided by V2 final minus V2 initial. Now some huge simplification happens here. So if you recognize that you have a term like a squared minus b squared divided by a minus b, remember that you can factor a squared minus b squared into the product of a plus b and a minus b, and the denominator is still a minus b. So these two go away, and we're just simply left with an a plus b term remaining. And that's exactly what we have here in our velocity equations. So where we have here in the numerator v1 initial minus v1 final with each of them squared, this whole term just turns into a v1 initial plus v1 final. And then similarly for the right hand side, we just get v2 final plus v2 initial. Now if you remember from equation 6, which is here in the top left in yellow, we want to collect the terms, which are the final velocities. Excuse me, this should be a v1 final as well. Copied straight from the lab manual, equation 6. So we're going to collect the terms which have final on one side, and then collect the terms which have initial on the other side. So I'm going to start with here, v2 final, and I'm going to bring v1 final over to the other side. Now I'm going to bring down the v1 initial, and then bring the v2 initial from the right hand side over to the left hand side. And then I can divide the left hand side of this equation into the right hand side. So rewriting the right hand side here, and then dividing by the left hand side. And of course, that gives me a 1 on the other hand side of the equation. And if I switch the order on these two, it's the same as multiplying through by -1. So that makes this -1. And there we finally have equation 6. V2 final minus V1 final divided by V2 initial minus V1 initial is all equal to -1. But we assume the conservation of momentum and the conservation of kinetic energy. So keep in mind that this is assuming that the COM, conservation of momentum, and the conservation of kinetic energy is true, which means this only works for elastic collisions. Only. Alright, I'm going to be posting this to our Blackboard under the one-dimensional lab folder. Hopefully this helps you all out in your discussion and analysis sections a bit. And that's it for now.